Hi, we are a team called sudo bash and the name of our application is LimeLight. LimeLight is a disaster management ecosystem that looks to tackle some of the core challenges that present-day disaster relief faces. The primary task for rescuers in the aftermath of a natural disaster is to start an immediate search for survivors. However, a major chunk of the rescue effort is wasted since the rescuers do not know the exact locations of victims and hence have to employ a probabilistic approach to finding survivors. For example, consider an individual A trapped in the wreckage caused by an earthquake. If A has the LimeLight app installed in his or her phone, the app shall run a background service to routinely update an Azure central server with A's exact location. But what if A's phone doesn't have internet connectivity? This is a reasonable question considering the event of a disaster. LimeLight tackles this by using Wi-Fi direct channels to connect devices to one another. Using Wi-Fi Direct's range of 60 meters, A's device shall ping other devices with A's exact location. On completion of the Wi-Fi Direct handshake, the location data is exchanged between connecting devices. This data is then passed on to other devices. As soon as a device with internet connectivity receives this data, it is sent to the central server. The central server responds with the location of rescuers, which is backpropagated throughout the relay network and made available to each victim. In this way, LimeLight ensures victim identification even in the case of a lack of internet connectivity. LimeLight rescuers are asked to identify themselves into one of three categories: scouts, medics, and lifters, each of them playing a dedicated role in the relief efforts. Victim locations are rendered in clusters. Clicking on a cluster displays information about its relief deployments. Rescuers can assign themselves to a cluster. Rescuers can also request for reinforcements in a cluster and specify the different manpower requirements. LimeLight uses reverse geocoding with Bing Maps Location API to send a message to rescuers with the exact coordinates where reinforcements are needed. Victims can also mark themselves as safe in LimeLight. On doing so, their location is hidden from the map interface. To improve the efficiency of rescue operations, LimeLight also provides a one-click chat interface through which victims and rescuers can easily communicate with each other. This is useful for coordination purposes and to quickly transmit ground-level requirements. An important component of disaster management is aerial surveillance. This is especially crucial immediately after a tragedy to get an idea of what actually transpired on the ground. Aerial surveillance can also be used to locate victims in remote areas. LimeLight empowers aerial surveillance through Microsoft-supported commercial drones. LimeLight provides a drone management interface through which rescuers can deploy drones, navigate them, and examine their live video streams. Rescuers can mark victims appearing on the drone's video stream. On doing so, a message is sent to all the rescuers containing the victim's location obtained via the drone's GPS coordinates. However, What if a victim is not spotted by the drone's camera? This is entirely possible if the victim is stuck under rubble, like in the event of an earthquake. Using image recognition and computer vision algorithms won't be very helpful in a scenario where a victim is in the drone's blind spot. So LimeLight handles this by automatically connecting the victim's device to the drone's Wi-Fi hotspot network. The victim's location is sent to the drone through the Wi-Fi channel. Since the drone is continuously in motion, whenever it comes within the proximity of a rescuer, its entire locational data is sent to the rescuer. In this way, LimeLight is able to locate victims in areas with no internet and no cellular connectivity. In our model, drones are the carriers of locational information between victims and rescuers in the entire disaster zone. Our future vision for LimeLight is to evolve from the existing manned drone surveillance system to a completely autonomous one via a delay tolerant network. This network will have persistent exchange of locational data between drones, victims, and rescuers. Using a swarm of Microsoft-supported drones, our current model can be upgraded to perform autonomous and exhaustive surveillance of the disaster site, even in the absence of internet and cellular connectivity. In this way, LimeLight is a disaster management ecosystem that aims to revolutionize how present-day relief efforts work. Thank you.